Germany's Mini Taurus, revolutionizing tactical air defense through AI integration in the rapidly evolving landscape of unmanned aerial vehicles, UAVs. Germany's development of the AI-powered Mini Taurus represents a significant leap forward in autonomous defense technology. This sophisticated system combines the proven capabilities of the original Taurus KEPD-350 missile with cutting-edge artificial intelligence, all in a more compact and versatile package designed for modern tactical operations. The evolution of the platform, the Mini Taurus, emerged from Germany's commitment to modernizing its defense capabilities while addressing the changing nature of modern conflicts. Building upon decades of experience with the full-size Taurus KEPD-350 cruise missile system, German defense contractors have created a smaller, more adaptable platform that maintains impressive strike capabilities while introducing advanced autonomous features. Technical innovation at the heart of the Mini Taurus lies a sophisticated artificial intelligence system that represents a significant advancement in autonomous operation capabilities. The platform integrates multiple AI subsystems that handle everything from navigation and threat assessment to target identification and mission planning. These systems work in concert to create a highly capable autonomous platform that can operate effectively in contested environments. The vehicle's reduced size compared to its predecessor brings several advantages. With a length of approximately 2 meters and a significantly lighter payload, the Mini Taurus can be deployed from a wider range of platforms, including smaller tactical aircraft and even some larger UAVs. This versatility dramatically expands its potential applications while reducing the logistical footprint required for deployment. AI integration and capabilities. Advanced decision-making. The Mini Taurus's AI system represents a new generation of autonomous decision-making capabilities. The system processes data from multiple sensors in real time, creating a comprehensive situational awareness that allows for sophisticated tactical decisions. This includes navigation and path planning. The AI system excels in autonomous navigation, utilizing advanced algorithms to plot optimal flight paths while considering multiple variables such as terrain, weather conditions, and potential threats. The system continuously updates these calculations during flight, allowing for dynamic route adjustments as conditions change. Target recognition and verification. Perhaps the most impressive aspect of the Mini Taurus's AI capabilities is its advanced target recognition system. Using multiple sensor inputs and sophisticated pattern recognition algorithms, the system can identify and verify targets with remarkable accuracy while minimizing the risk of collateral damage. This capability represents a significant advancement in precision strike technology. Operational advantages. Enhanced survivability. The Mini Taurus's reduced radar cross-section, combined with its AI-driven threat assessment and evasion capabilities, provides superior survivability compared to traditional systems. The platform can autonomously detect and respond to threats, adjusting its flight path and employing countermeasures as needed. Mission flexibility. The system's compact size and advanced AI enable it to perform a variety of missions beyond traditional strike operations. The Mini Taurus can be configured for reconnaissance, electronic warfare, or even serve as a communications relay, with its AI system optimizing performance for each role. Network integration. Modern military operations increasingly rely on networked systems, and the Mini Taurus excels in this domain. The platform can seamlessly integrate with existing command and control networks, sharing data and coordinating with other assets to enhance overall mission effectiveness. Technical specifications. The Mini Taurus combines sophisticated hardware with advanced software systems. Key technical specifications include physical characteristics. The platform features a modular design that allows for rapid reconfiguration based on mission requirements. Its composite construction provides an optimal balance of strength and weight, while advanced stealth features help minimize its radar and infrared signatures. Propulsion system. An efficient propulsion system provides extended range while maintaining a low thermal signature. The AI system continuously optimizes engine performance based on mission parameters and environmental conditions. Sensor suite. The Mini Taurus carries a comprehensive sensor package that includes multispectral imaging systems, advanced radar systems, electronic warfare sensors, environmental monitoring equipment, operational impact. Tactical advantages. The introduction of the Mini Taurus represents a significant enhancement to tactical air operations. Its ability to operate autonomously reduces risk to personnel while providing commanders with new options for precision strike and reconnaissance missions. Strategic implications. The system's development reflects a broader trend toward autonomous systems in military operations. The Mini Taurus demonstrates how AI can enhance military capabilities while potentially reducing the risk of collateral damage through improved precision and decision-making capabilities. Future development. Ongoing improvements. Development of the Mini Taurus continues, with regular software updates enhancing its AI capabilities. Research focuses on improving autonomous decision-making, expanding mission capabilities, and enhancing integration with other military systems. International collaboration. The project has attracted interest from several NATO allies, potentially leading to international collaboration in further development and deployment. This cooperation could help establish new standards for autonomous military systems while ensuring interoperability among allied forces. Ethical considerations. The development of autonomous weapons systems like the Mini Taurus raises important ethical questions. German developers have implemented strict ethical guidelines in the AI system's decision-making protocols, ensuring human oversight remains central to combat operations. Human control. While the system possesses significant autonomous capabilities, it operates within carefully defined parameters that maintain meaningful human control over critical decisions. This approach balances the advantages of AI with ethical responsibilities. Safety protocols. Multiple redundant safety systems ensure reliable operation while preventing unauthorized use or manipulation. The AI system includes sophisticated self-diagnostic capabilities that can detect and respond to potential malfunctions. Conclusion. The Mini Taurus represents a significant advancement in military UAV technology, demonstrating how artificial intelligence can enhance military capabilities while potentially reducing risks to both operators and civilians. Its development reflects broader trends toward autonomous systems in military operations while highlighting the importance of maintaining ethical guidelines and human oversight. As development continues and the system proves its capabilities in operational testing, the Mini Taurus may well serve as a model for future autonomous military systems. Its combination of advanced AI, reduced size, and enhanced capabilities offers a glimpse of how military operations may evolve in the coming decades. The success of this program also demonstrates Germany's growing capabilities in military AI development and could influence future international collaboration in defense technology. As autonomous systems become increasingly important in military operations, the lessons learned from the Mini Taurus program will likely influence the development of future systems.